Okay, so today we're going to do a practice assessment over how to use 5 of the characteristics of the 7 that we have learned so far. To pick an appropriate graph, we'll also need to be able to explain and complete sentences using proper mathematical language on how we use these to identify the correct graph. So in this text box on your provided part of your review notes in the back of the packet, you'll see these text boxes here at the bottom. We're really only going to choose 5 of these, and I'm not going to take your time on all 7 today to talk about. The function would be given to you at this point, but on this one, I have it kind of left out. But the function that we need to be looking at is this, and then we'll come back to part B and choose the correct graph. So let's go ahead and rewrite the function from page 2. So the function is p of x equals x to the third minus 2x squared minus 15x. And it won't necessarily be in this order, but you do need to memorize the 5 that I'm going to talk to you about today and be able to talk about them. I feel like we have done this quite a lot in this unit so far. So I think you'll be definitely capable. One thing we will do is the zeros or the x-intercepts, okay? I'm not going to talk about odd and even powers to identify it. We'll talk about the y-intercepts. We'll talk about the far left and far right behaviors of the graph. We'll talk about how many turns there are in the graph. We're not going to talk about discarding rule signs, but we will talk about number of zeros. And really, you could do this in any order that you want. So I'm going to come down here. This would be the 5th thing that on the page anyways, that we're going to talk about. So number of zeros, we can find the number of zeros by looking at the leading exponent. So we know there's 3 zeros. Turns, I'm kind of working my way up, it seems. Turns, I take the leading exponent and I subtract 1 from it, and that tells me there's 2 turns. My far left and far right behaviors. So this goes to, we're looking at our leading term again. All 3 of those, we've looked at that leading term. And I can tell that my right-hand side is going to go up because it's a positive leading term. And then my left-hand side is going to do the opposite because my exponent is an odd number. So it's going to go down. I think I will just definitely go from bottom to top in answering this. I'll go ahead and do y-intercepts. So y-intercepts mean that you replace x with 0 and simplify. So 0 to the third minus 2 times 0 squared minus 15 times 0. So y is 0. So that means my y-intercept is just going to be at the origin. What helps us a lot identifying the graph is going to be our x-intercepts or our zeros, and also those far left and right behaviors, as you know. So this is where we need to factor this polynomial. So I'm going to pull out an x as the GCF, and that would leave me with like an x squared minus 2x minus 15. Then I would factor those 2 parentheses down further using opposite signs. If I take 3 times 5, I could get negative 15. If I had a negative 5 and a positive 3, I'd get that negative 2. So x plus 3, x minus 5 are my factors. So x equals 0, x plus 3 equals 0, and x minus 5 equals 0. So we're finding the zeros so we can identify the x-intercepts. So, you know, we replaced y with 0 in this case. So 0, 0 would be one of the x-intercepts since x equals 0. This one, we would get x by itself, x equaled a negative 3. So negative 3, 0 would be another intercept. And then we would add 5 over, and x equals a positive 5. So 5, 0 would be the third intercept. So we knew there were going to be 3 zeros. We kind of said that to start out. 3 zeros means 3 intercepts. So once we've kind of identified 5 of those 7 things that we've learned so far, we are asked to explain and complete sentences using proper mathematical language. And really, it's everything that I was saying verbally when we were going through and identifying, your x-intercepts or your zeros. So for instance, for the x-intercepts, the zeros of this function that we were given, I would just state, and it doesn't have to be super detailed, but I would just say, I factored the function to find the x-intercepts for the graph. So we used some mathematical language. Factoring is a mathematical language. The function is a mathematical language. And I would, in Word, you need to actually state, this means, not they, this means there are points on the x-axis at, and then you can identify those ordered pairs at 0, 0, -3, and 5, 0. Okay. And it doesn't have to be in the exact words, but like, tell me how you found those x-intercepts and what does that mean for this graph? So for me, it just means that's where you're going to have points, on the x-axis that we've talked about so far in this unit quite frequently. The second thing that we identified was the y-intercept. I would just say I replaced the x values with 0 and simplified to find the y-intercept, that's a t, is at 0, 0. So again, like that's where it's crossing the y-axis as well when we found that. The third thing we did was our far left and far right behaviors. Okay, so that's where we identified the leading term. So I would state the leading term is x to the third. The far right of the graph will go up since it is a positive term, or you could say since it has a positive coefficient, I suppose. The left of the graph will go down because the exponent is odd. So you're basically telling me, how do you know that the behavior of the graph that the far right and the far left would be going up and down like so? So you should be able to kind of sketch a real rough sketch without using a graphing utility. By knowing that information so far, the other two that are very easy to identify would be like turns. You could say, I identified there are 2 turns in this graph by subtracting 1 from the leading term or the biggest exponent, whatever you want to say. So you could say the leading terms exponent because the leading term always has the biggest exponent, or you could just say one from the biggest exponent. So you've told me there's two terms. So not only, when you're writing this in a sentence, not only are you telling me what you did, you're telling me what you found as well. So notice I do still, even though in my work I identified my x-intercepts, for example, for one, we still need to state that, but we need to tell like how I did that. How did I find that? How did I know the y-intercept, which I really messed my C up. My y-intercept is 0, 0. How did I know that? I just tell how I did it. I replaced the x values with 0 and simplified to find my y-intercept is 0, 0. So you need to state the y-intercept within your sentence. You need to state within your sentence. Don't just tell me how you find the behaviors. Tell me this leading term for this function itself is x to the third. So the far right of the graph is going to go up since it's positive. The left is going to go down because it has an odd exponent. Okay, tell me exactly to this term exactly what it is. And then number 4, I identified there are two terms in this graph because I subtracted one from the biggest exponent, or like I said, it's probably more official to say the leading terms exponent. Whichever one is really going to work fine with me. But like if you're using terms like exponent and leading term or subtracting, those are mathematical words. It doesn't have to be super difficult. Number 5, zeros. How did I know that there would be 3 zeros in this function? I would just state the biggest exponent is 3. This means there are 3 zeros for this function. So all stuff that we say when we're talking about it, and that's really all I need you to put into words, complete sentences. It's not like I take off for spelling. I obviously don't have the best handwriting, but do try to write it in a way that you can read it. So using this information, we need to go pick the right graph. First of all, I would take a look at the x-intercepts, and the x-intercepts are 0, 0. So that's here, 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 and here. So that doesn't really get rid of any of it. -3 is right here, so it shouldn't be this one. -3 is this one. -3 is this one, so it shouldn't be this one. And -3, 0 is that. So we have these two graphs, and they both go through 5. This is where your far right and far left behaviors are probably going to be what determines between the two. So remember, we said that my far left and far right meant my far right, since the leading term was positive, it should be going up. And this is the one that goes up, and the far left should be going down. So while these two graphs have the same exact intercepts, this one, the right-hand side is going down, so this one would be incorrect. Okay, it is different. They might go through the same points, but that's why you have to know all those characteristics so that you can pick the appropriate graph. So you should be able to do this with another function and be able to identify all 5 of these traits. I'm not going to have you do these two, but I'll have you do all 5 of these specific traits for that function itself that I give you.